Yes, hello everyone, welcome on YourPedia platform. I hope you all are fine, preparing well. So guys, as you know, we are covering important interview questions through this interview question series for PSUs and IITs. And in today's session, we are going to discuss what is compressibility factor, which is actually generally represented by Z. So what is that compressibility factor? What is the use of the compressibility factor? What is reduced pressure? PR, what is reduced temperature, TR, and why they are required, what is the use of those reduced pressure and reduced temperature. Okay, so the interviewer can ask you these type of things. So let us discuss what is compressibility factor, guys. This compressibility factor is nothing but it is represent the ratio of the actual volume of a gas, actual specific volume of a gas in relation or in with relative to the ideal volume of that gas. Okay, you know guys, ideal gas equation PV equal to MRT. This is ideal gas equation, or you can write it here P specific volume V equal to RT, or from this you can write the specific volume of an ideal gas. This is the specific volume of an ideal gas at a particular pressure and at a particular temperature is nothing but RT by P. So the ideal volume, the specific volume of an ideal gas is equal to RT by P at a particular temperature T at a particular pressure P. So the ratio of the actual volume of a gas V actual divided by ideal volume, and ideal volume is nothing but RT by P at a particular pressure. So the gas which you are having, the real gas which you are having, the specific volume of that real gas you are comparing with the specific volume of an ideal gas at same pressure at same temperature T. So T is the temperature of the real gas, P is the pressure of the real gas at that particular pressure, at that particular temperature. What is the specific volume of an ideal gas? What is the specific volume of an real gas? If they both are very much close, means if compressibility factor is close to 1, or if it is exactly 1, it will be exactly 1 for ideal gas only. Z will be exactly 1 for an ideal gas. And if you are having Z close to 1, it means the real gas can be considered as an ideal gas. Real gas can be considered as an ideal gas. Can be considered as an ideal gas. Go to the point, guys. Okay, so this compressibility factor is nothing but it is also known as gas deviation factor. इसे हम क्या बोलते हैं? Gas deviation factor, because it tells us about the deviation of a real gas from the ideal gas behavior. Okay, so for ideal gas Z will be equal to 1, but for real gas, the Z can be less than 1, Z can be greater than 1, or Z can be close to 1 also. If it is close to 1, the behavior will be very close to the ideal gas behavior. If it is very very low as compared to 1 or very very high as compared to 1, means the behavior of that gas is very much far away from the ideal gas behavior. But for ideal gas, Z will be equal to 1. Okay, what is that, guys? This is known as compressibility factor or gas deviation factor. It is a ratio of V actual by V ideal. But how actually we define and how we calculate those Z value for different gases, that we are going to discuss. And what are those reduced pressure and reduced temperature? So guys, you know, last class I told you there is a percentage error, there is a term which is known as percentage error, and which is nothing but the actual volume of a gas, the ideal volume, okay, divided by V actual. You can take mode of this because sometimes the actual volume may be higher than ideal, sometimes the ideal volume may be higher than that. So you need to take mode of this, multiply by 100 percentage. If this percentage error is less than 1%, अगर ये क्या होता है less than 1%, okay, if this percentage error is less than 1%, और इसको मैं fraction में लिखना चाहूँ, then it will be 0.01, okay, 1% or 0.01. So if this percentage error is less than that, then you can consider that gas as an ideal gas. Okay, this is one criteria. Another I told you with Z, the compressibility factor Z, if it is close to 1, then also you can consider that gas as an ideal gas. But now the question arises, you know, the different gases, they are having different boiling point, they are having different melting point. So if you want to define some kind of high temperature, high pressure, that is very difficult to define, because the high temperature criteria and the low pressure criteria will be different for each and every gas, because different gases, they are going to behave differently at different temperature pressure. That's why some kind of reduced pressure and reduced temperature of the gases are defined. So let me tell you first what you understand by reduced pressure. Okay, so guys, the reduced pressure is nothing but the pressure of a gas in relation with the reduced, in relation with the critical pressure, something like this. So let me write it here, PR. PR is nothing but the pressure of a gas. P is the pressure of a gas divided by P critical. What is TR? TR is the reduced temperature, the temperature of a gas in relation with the T critical. You know guys, suppose water vapor, the steam you are having at suppose 150 degrees Celsius. So if you will convert it into Kelvin, the temperature of the gas at that particular condition, the temperature of the gas, critical temperature, which is 374 degrees Celsius. So that ratio is known as what? Reduced temperature. Similarly, for water, suppose you are having steam at suppose 2 megapascal, 5 megapascal. So that is the pressure of the steam. What is critical pressure for the steam, guys? Critical pressure for the water is close to 22 megapascal. So the pressure of the steam, the pressure of the water vapor in relation to the critical pressure, the temperature of the steam in relation to the critical temperature, that is known as a reduced temperature and reduced pressure. Why these are defined, guys? Because it is observed for different gases like methane, ethane, ethylene, propane, butane, different gases. If you will observe their behavior at same reduced pressure, at same reduced temperature, their Z value will come out almost same. So these are the different, guys, you know, that like triangle, square, these cross, these are representing different gases. But what is common, guys? These gases are at same reduced temperature. This is reduced temperature 1.3. This is reduced pressure which is close to 3.8. So these gases I am considering at a same reduced pressure. Okay, at a same reduced pressure and at same reduced temperature. So at that condition, their Z is also coming out almost same. Unka Z kya hai bachcho? Z is almost same. Like you can observe it here. There is very less, you know, difference. So Z is almost same, which is close to what you can say 0.68. Okay, close to that, 0.68. And at any other temperature also you can consider, suppose say this here also, like yahan le lete hain. So what is this here? What is the reduced pressure? The reduced pressure is close to 1.2. What is the reduced temperature here, guys? This is reduced temperature line, same 1.3. So here these are the different reduced temperature line, guys. This is reduced temperature 1, this is reduced temperature 1.1, this is reduced temperature 1.2, this is reduced temperature 1.3, reduced temperature 1.5, reduced temperature 2. These are this, and on x-axis you are having reduced pressure, and on this y-axis you are having compressibility factor Z, guys. This is compressibility factor Z on the y-axis. Got the point? So here the reduced pressure for these gases is almost same 1.2. The reduced temperature is also same, almost close to 1.3, and at that same reduced temperature, same reduced pressure, their Z will come out almost same. So what you need to understand, why that reduced temperature and reduced pressure are defined? Because the critical temperature, the critical pressure, the boiling point, melting point, those are different for different gases. But it is observed experimentally, if you are taking different gases at the same reduced temperature, at same reduced pressure, their, you know, behavior is coming out same. The ideal gas behavior, that is coming out same. Why? Because their Z value is coming out almost same. So it is observed experimentally, if you will take different gases at same reduced pressure, at same reduced temperature, their Z value, the compressibility factor will come out same. That's why these two factors are defined, the reduced pressure and reduced temperature, the pressure, the temperature of a gas in relation to their critical temperature pressure. This term will be different, guys. Critical temperature, critical pressure for each and every gas will be different. What is the point? So the temperature pressure of those gases in relation to their critical temperature and critical pressure, that is known as reduced pressure and reduced temperature. So this is known as a compressibility chart. इसे हम बोलते हैं बच्चों compressibility chart. Okay, and if you know the reduced temperature, like suppose for water, if I will give you the temperature of a water vapor, the pressure of a water vapor, critical temperature, critical pressure, you know, for the water, so easily you will be able to get the value of reduced pressure, reduced temperature for the water, and based on that easily you will be able to check what Z value you are getting. So if you are getting Z value close to 1, means you can consider that gas as an ideal gas, but if you are far away from that, then the behavior will be away from the ideal gas behavior. So if you will check it here, guys, in this graph, if you are having a gas at a very low reduced pressure, means I told you, if you are having a gas at a very low pressure, so if pressure is very low, then PR, reduced pressure, will be very less than 1, because if pressure is very high, then this term will be, PR will be more than 1. Got the point? But if pressure is very low, the gas pressure is very low, then PR will be very less than 1. So if you are having reduced pressure very less than 1, irrespective of temperature, we can consider gas as an ideal gas. Gas can be considered as an ideal gas. Go to the idea, guys. Why? Because if you will observe it here, the reduced pressure is less than 1. Reduced pressure is less than, very less than 1, guys. So you will go into this region. Reduced pressure very less than 1, irrespective of any temperature, whether you are having reduced temperature 2, reduced temperature 1.5, because these all line they are going to merge here. यहाँ पे क्या हो जाएंगे? They will merge here. Okay, so irrespective of temperature, if the reduced pressure is very less than 1, the gas behavior will be very close to the ideal gas behavior. Why? Because Z will be very close to the 1. This is one very important point you need to know. Another point, if you are having gas at a reduced temperature Tr greater than 2, okay, the Tr reduced temperature is greater than 2, okay, but यहाँ पे दूसरा condition क्या है? But except Pr not very high. Except Pr not very high. Pr बहुत ज़्यादा high नहीं होना चाहिए बच्चों. If Pr is very higher than 1, and then if you are having reduced temperature close to 2, then you are not going to have ideal gas behavior. But if the reduced temperature is greater than 2, and except बोल रहा हूँ मैं, except Pr very high, then you are not going to consider ideal gas behavior. But if it is not there, the pressure is not very high, it is normal, okay, and the reduced temperature is greater than 2, then also you can consider gas as an ideal gas. Why? Because you will have Z close to 1, because you will have a line something like this, you will have a line, and on this line, guys, you can observe the Z will be 1. For an ideal gas, you will have a horizontal line. Ideal gas के लिए क्या मिलेगी आपको? Horizontal line, because for ideal gas, irrespective of any reduced temperature, reduced pressure, the Z will be exactly 1. So that's why you are going to get a horizontal line for the ideal gas. So go to the point, guys. This is first conclusion. This is second conclusion. The reduced temperature is greater than 2, except the pressure is not going to be very high, then also you can consider gas as an ideal gas. Third, which is very important point, guys, which you need to understand, if you are having a gas close to its critical point, the gas is close to its critical point, the behavior is very far away from the ideal gas behavior. In the earlier also, guys, that question which we have discussed, the ideal gas behavior, so I have shown you some diagram. In that diagram, you know, the ideal gas behavior will be far away from the critical point. At critical point, the gases are not going to behave as an ideal gas. Here also, if you can check, if you are having a P, both they are equal, the P equal to P critical, T equal to T critical. For example, both P are close to 1, T are close to 1, means at critical point, So at critical point, reduced pressure will be 1, reduced temperature will be 1, and you will be somewhere here. You will add somewhere here. Reduced pressure close to 1, reduced temperature close to 1, because this is the line which is belonging to reduced temperature 1. And at this particular point, guys, the Z is very low. So the behavior of the gas will be far away from the ideal gas behavior. If the reduced pressure equal to 1, reduced temperature equal to 1, means you are very close to the critical condition. So close to the critical condition, the gases are not going to behave as an ideal gas. Generally, students think that critical point is very high temperature, very high pressure. So at that pressure, temperature, we can consider gases as an ideal gas. The answer is no, because at critical point, the behavior of the gas will be very far away from the ideal gas behavior. So if the reduced temperature is increasing, like at very high temperature, more than its critical temperature is increasing, reduced temperature is this, and the pressure is what, the reduced pressure is also lower, it is not very much high. Very much high means, suppose if you are having reduced pressure more than 7 is very higher as compared to 1. So reduced pressure अगर आपका बहुत ज़्यादा high हो जाता है बच्चों, so these lines they will go actually something like this. ये कुछ ऐसे चली जाती हैं. These lines will become something like this. Then also the deviation will be very high. So the second condition which I mentioned, reduced temperature close to 2, but except the pressure is not required to be very high, because if the pressure is very high, then these lines will go something like this. The behavior will be far away from the ideal gas behavior. But if the pressure is lower than that, suppose reduced pressure is lower than 6, 7, okay, lower than that, and the reduced temperature is high too, then also you will have a ideal gas behavior because the Z value will be close to 1. So I hope you got the idea about this compressibility factor. What is compressibility factor? What is reduced pressure? What is reduced temperature? What is Z value for ideal gas? What is Z value for real gas? And how we can define this Z value? Okay, and how you can plot what is compressibility chart and why actually we are defining those reduced pressure and reduced temperature. Okay, because at same reduced pressure, same reduced temperature, the behavior of different gases will be almost same. Their Z value will come out almost same at same reduced pressure and same reduced temperature. Okay, so I hope guys this is clear to you. Again we will meet and we will discuss some more interview questions. So please keep revising the things and keep preparing. So thank you very much. Have a nice day. Good luck.